Welcome to the second semester and the start of our entire interdisciplinary seminar series, which is really the core seminar of the Institute for Humanities in Africa at UCT. We are privileged this semester to have a really good collective of scholars who are visiting through many different programs and projects, but coming from across the African continent, from different parts of the world, and especially also from Brazil. I wasn't going to say South or Latin America. We don't know what to say these days, but let's just say that they're coming from Brazil. Which is also a really good partnership, to develop and increasingly building the relationship between the South, within the South, and also within the BRICS context, and also with contexts that have questions around decolonization and decoloniality is really critical. We last week commemorated the passing on of our colleague Abonga Sitela, and it was a beautiful conversation with different colleagues, and we always start the year by commemorating but celebrating him and the ideas that he, as a person, represented. Thank you. Noran is announcing that there's stuff to eat. Food is always good. But really celebrating not just him, but his ideas, but also the place which allows us to do this work that we do now. We will know that the university has become a very contentious place globally. It is the space for lots of polarizations, and it is the place also where it's become the frontier for the state. It's become the frontier also for whether it is what is called the left wing or what is called the right wing, or up and down. So I think we are grateful to have a space where we can actually come together as a community and also have conversations across each other, interdisciplinary conversations, and in an open and also generous manner. So we also thank many of the colleagues who have agreed to come here despite the challenges and difficulties of having to come, and hoping that the ones who are still waiting to come will join us, however the challenges, whether in person or virtual. So today we have the privilege of hosting Dr. Messi Nguelé Thomas, which we'll call Messi, and to emphasize that it has nothing to do with Messi in Argentina. But that's very important to underscore. It's just a coincidence that someone else is named Messi. We play soccer, but Messi is a name from Cameroon, which is very much also shows you the plurality of the world, But he is trained in political science, computer sciences. There are not really lots of political scientists this time. from the University of Grenoble with the Alps, and also the University of Yaoundé one, where he is also based, both as a lecturer and also he's the head of the Department of Computer Engineering at the University of Bolova in Cameroon, and also the head of the Computer Science and Applications Laboratory at AMBA. So it is such a pleasure, to also have a young scholar whom we interacted and met within the AI4D scholarship, the Africa Center for Technology Studies, There's several of them in this cohort. Susan Okego, who also came from there, and Ogochi, who is not here, who also came from that cohort, and who have now evolved to establish one of Africa's AI institutes. So it's really good to have these colleagues, to be with us today. But he's got lots of different fellowships that he has accumulated over the time, and well-decorated scholar, and also published scholar in his field, in computer engineering and technology. But he's here thanks to the Carnegie Corporation of New York and the deal, what is called the deal HUMA grant, which is ending this year and probably continuing to next year, which is really around Africa AI ethics and questions around how to think AI through African epistemologies and questions of ethics. Messi is going to speak to us today about complex questions around complex machine learning systems. And we are going to give him 20 to 30 minutes to speak. And then after that, we have a very good conversation. So thank you for being here. You're welcome. And we look forward to hearing and listening to your presentation.
Okay. Thank you for thank you, Prof. Divine, for introducing me. Thank you for inviting me so far. So thank you for attending. So as Prof. Divine said, I am a computer scientist, but I want to introduce or strength in ethical content in my work. So I invite you to help me to try to see how I can introduce this ethical concept. So my presentation is about efficient complex system analysis on parallel architecture, so with ethical machine learning. So this is the agenda. So I will first talk about the generality about artificial intelligence. So I will call it. Then I will talk about my main research problem. So, and I will also present how I use artificial intelligence to solve my problem, computer science problem, or computer science problem identified computer science context. So it will be numbering-based machine learning and also parallelization of machine learning algorithms. So the first point, generality on artificial intelligence. So artificial intelligence usually deal with try to make computer behave like human. And then we have many tasks in artificial intelligence. You have this big task called machine learning. Machine learning is also a task of artificial intelligence, but we have many tasks of machine learning. I will discuss of it in the next slide. And then we have also other tasks like reasoning. We want to make or deduce, make a machine reason or deduce from fact. You have planning, that is construct, make a machine construct a sequence of action to achieve the goal that we define, or knowledge representation. So we help we write a code we have a program to make the machine, the computer, to organize or represent knowledge as human. We have also perception. We use to put sensor so that the machine can perceive things like human. Motion and manipulation is how manipulate object, pulling, pushing. is what we usually see on robot or social intelligence. So here we need the machine to understand human emotion or interaction or general intelligence. Here we want to make the computer have global intelligence that coordinates other intelligence. We also have natural language processing as another task of artificial intelligence. This here is understand how to understand, interpret, writing speech, writing, manipulate language like human. So now you also have, as I said, machine learning with the big task. And we have subtasks of machine learning. So we have supervised learning. This allow a classification based on allow machine to do a computer to do classification based on human labeling. We have also on the unsupervised learning. This year we do not have label, but we build an algorithm that will allow the computer or the machine to categorize or to do this classification without helping it. We also have semi-supervised learning. This is the mix between supervised and unsupervised learning. We also have what we call reinforcement learning. Here we build the model based on the experience. So the machine build the model looking at failure or success. So the failure or the success will guide the computer to build this model. We also have transfer learning. Here we already have a model and we use this model to build another. We also have deep learning. In deep learning usually deals with many layers. For example, we have it with RNN, recurrent neural network, graph neural network, convolutional neural network. So I will say something there. So the goal in machine learning or in artificial intelligence is, as I already said, is to make the machine behave like human. But the key word is data. Yes. So we have two big types of user. We have artificial intelligence model builder, is the mostly computer science, focusly in data. We call them data scientists. And we have AE, artificial intelligence model user. Can also be computer science. We take this model to build other application, or non-computer science who can use it to solve problems. Okay, something about ethical. So ethical, I think that here you are normally you should know it better than me, but I will say something. Ethical in artificial intelligence, according to Microsoft, for example, deal with 6 things. The first thing is fairness. So here, artificial intelligence models should treat everyone fairly, equitably, or fairly, let's say fairly. We also have inclusiveness. Here, the model build should not exclude people or exclude things. We also have reliability and safety concern, that here the model build should operate as they were originally designed. So if you design it to maybe to detect hate message, it has to detect every kind of hate message. We also have transparency. So model builds should help people to understand the decision that that they did. We also have privacy and security here. When you, as we already said, the keyword in machine learning or artificial intelligence is data. But when you use data, we should ensure privacy and also security. So we should not expose maybe user information and so on. We also have the last one, accountability. So here it is, we should know who is the responsible, who is accountable. Is it the guy who built it or the one who is using it? So accountability is make sure that when you use or you build the model, we can have issue if the model does not work correctly or cause some problems. Okay, so how do I use machine learning? So I will start with my main research problem. I will first start with the context and the problem. What do I want to solve? So I am in complex system. Usually, you say that complex system is a set of component in interaction with a behavior difficult to model or to predict. So, for example, you can have nervous system. Nervous system are an example of a complex system, or social network is another example of complex system. So the interesting thing is that complex system usually generate a large amount of data day by day. So if I take Facebook, and if you look at active user, for example, in 2013, you have 1.13 billion active user. In 2021, you have 1.88 billion. And now we already have 3 billion, almost 3 billion of active user in Facebook. That means that data are generated day by day, and that is very difficult to process. We also have, as I already said, machine learning. Machine learning is a part of artificial intelligence where algorithms automatically learn to perform a task from data, as I already said. But machine learning is well suited to process data coming from complex systems. So it consists of training a model with those data to solve many kinds of problems. It can be regression problem, classification problem, or clustering problem. But one thing we should know is that the quality of the final model depends on the amount of data. So if you have a large amount of data, you have a better model. But the time to build this model will be also be high. So in my work, I want to reduce this time, the time of building, the time taking when build a machine learning model that will work on complex system. So I want to take advantage to multi-core architecture. As we see, for example, your computer can have 2 or 3 or 5 processors. So if the program is not designed well, is not designed to be parallel, this program will not fully use the computer. So my concept, my work is to build parallel program that will use all the potential of the computer. So to solve the problem I have mentioned last, I will present here two kinds of solution. The first one is machine learning based heuristic. So that will allow me to reduce execution time, as I already said. So I will show you how I use execution traces, that is data of this application, in order to build these heuristics. I will also show you how we can parallelize machine learning model. So I will take an example of recurrent neural network. And finally, the third type of solution is build what we call domain-specific language, DSL, to automatically parallelize this one. Because parallelizing is not an easiest task, even for computer science. So I start with the first one, how to use machine learning to reduce the execution time of program. Here I will do it by numbering a graph. Here I am in a complex network context. So complex network analysis complex. Complex networks, it is also a kind of complex system I already said. Complex network are here entities, set of entities that are interconnected with links that can be friendship links. And you use to model complex network with graph. So complex network have many properties. I give here two properties. We have the computer structure and also the heterogeneity of node degree. So what does that mean? It means that, for example, in let's say in Facebook or Twitter, me, Messi, as an individual, if I am in those, if I am in Facebook, for example, I will have maybe 5,000 friends. But if you look at Messi, like the football player, he will have millions and millions. So this is the heterogeneity of node degree. So I am node, even Messi is a node, but we do not have the same degree. And this influence in computation. Also, we know that complex node network problems are usually irregular. So when you execute an algorithm or program that deal with complex network analysis, it is irregular. And also complex network usually, as already said, usually use a large amount of data that require HPC, high performance computing. So I will give you an example to see. For example, let's take CAT score. CAT score in computer science is used to, for example, to predict, to say that this node and this node will be connected in the near future. We also have things like page rank that measure the importance of a node in a graph in social media. CAT score, for example, I give you here many graphs. We have karate graph, which have 30 nodes or 35 nodes or 35 individuals. You have quantum pH node, which have 1,560 individuals. You have GBLP, GBLP, I don't know if you, GBLP is graphs, close to 200,000 of nodes, and also we have live journal who have close to 4 million of nodes. So if we execute the CAT score, so to make the prediction of here, we will see that with karate we can execute, you can make all the prediction. So you also ask if all the nodes will be connected to each other. We will execute it in 10 seconds. But in QuantPH, we will execute it in 3 hours. In GBLP, we will have 12 years. But if you try to execute it in live journal that has about 4 million nodes, we will take many years. Okay, so if you want to have the exact solution, so usually to avoid this kind of problem, you use approximation to calculate, or you can also use parallelism. So I choose to use parallelism. So the question is how to improve performance in computers in complex network analysis. The answer is we can use graph knowledge. So you remember the previous slides, I told you about two properties, heterogeneity of node degree, or community in complex network. But we can also use parallelism. So I have already shown it in my PhD thesis. But now I will show you how we can use machine learning. So first of all, what do I want to? What is it? I just present you the global idea. So in a computer, we have memory. We have main memory, and we also have what we call cache memory, and even what we call register. So when the processor is processing data, it has direct access to register. But if the data is not in the register, the computer, the processor have to take in the cache memory. So from register to cache memory, from cache memory to register, will take it takes a certain time. But if the data used to process is not present in the cache memory, then the processor will request it from the main memory, and that will take many cycles compared to taking it from the cache memory or taking from the register. So the goal here is to organize data in such a way that we avoid taking data from memory. So if we can organize data so that it will be almost present in the cache memory, so we reduce the number of cache misses and finally the execution time. So I don't know if you, but you have the idea. So this is my goal. So you can see here it's simple model of cache memory representation. So what you have to retain is that the main goal is to reduce the access time. So this is my goal. For that, I model the cache, and I model the access to the cache. And so finally, the number of cache misses can be viewed like this. And my goal is to reduce this number as far as possible. But it is in computer science, we call it NP-hard problem. So a problem that cannot be solved in polynomial time. So we need a heuristic to do it. So it is what I first did in my PhD with using knowledge in graph. But now I want to show you how we can use machine learning to solve it. And we call it NIMBAMAL. So the idea behind NIMBAMAL is numbering-based machine learning. Is to use execution traces. So we first execute an application, we record the execution traces, and then we analyze these execution traces, and we design, we renumber the graph in such a way that we are taking into account the previous execution, so that the nodes we have to be hypothesis node with close traces will share the memory locality. So the goal is to give them close numbers so that during the execution you reduce cache misses, and finally execution time. Here we will use an algorithm called the clustering algorithm. Another hypothesis is in the same trace, how can you give nodes the close number? Here is another algorithm that we use frequent item set, and I have a PhD student who is still working on this. So the solution of clustering is what I presented. When you do clustering, we need something we call distance. So the distance between two nodes, we define a distance between two nodes thanks to Alex Gross first work. So we were inspired by its distance, and then we defined this one. And with this distance design, we could now apply two kinds of clustering algorithm. We have the Cummings algorithm and also the hierarchical clustering algorithm. So we designed this algorithm, and we combined them with existing one, and we saw that all these things, just to say that using clustering algorithm, we reduce 39%. So we gain 39% of cache misses, and finally we reduce the execution time by 24%. So this is the first work where I show you how we use machine learning to reduce the execution time. Another, the second one is the parallelization of machine learning algorithm. here I will show you how to use recurrent neural network to detect hate messages. So the first thing maybe where we can see the ethical concern is in data collection. So first of all, hate speech can be defined as a type of communication that constitute an attack using or discriminatory language against a person or a group of persons. So bias that can lead to ethical issue are here in this definition, because there is no universal definition. This the definition I give, another one can give another definition. And also we have diversity in languages. For example, the way we speak French in Cameroon is not the way we speak French in Mali. So that if Cameroonian insult you or give head message, professional head message, you will not know that he is doing that. It's the same, for example, I think in Mali. So that the diversity of language can lead to ethical issue. We also have the freedom of expression or opinion, so that a person can say something depending on the way the place you are. They will say that you think that it is not hate message or it is. So during the data collection, we need both quantity and quality. Quantity here, because I already said it, the machine learning model is more efficient with the data quantity. So if we have a huge quantity of data, the model will be the quality of the model will also be higher. And also we have another thing, the quality. So for example, the quality here, being able to distinguish hate message, for example, from Cameroon and from Mali. So in data collection, we need to do all this quantity and quality. And actually, I have some students in Cameroon who are still collecting hate message from Cameroon. So if you have, for example, if you have not if you have, for example, people from Morocco who also speak French, you will be grateful to take to see how they speak French, how their hate message are. Is it like standard French or not? So that we can also add it in the collect data set. Yeah, so this data collection. But how do you do? You will see that you use a recurrent neural network to analyze all the data. So remember that my work as a computer scientist is my goal is to reduce the execution time. Yes, to have a model with higher quality and also with execution time reduced. So here to analyze hate message detection, so you use recurrent neural network. But recurrent neural network is normally, if you look at the algorithm, you will see that it is intrinsically sequential. So parallelizing it is not very easy. And in recurrent neural, we have three types of recurrent neural network. We have standard recurrent neural network. We also have what we call GRU and even LSTM. And we parallelize it using a technique called data parallelism. And we modify an algorithm called stochastic gradient descent. And the difference between what we propose and the existing work was in the way we aggregate. So in existing work, they used to do explicit aggregation, meaning that the worker, when they are building the model in parallel, they use an explicit aggregation function. So we saw that doing like this take more time, and also is waste some information. So we propose what we call an implicit aggregation. And we show that doing like this, for each of the three types of recurrent neural network, we have the beta solution. So this is the training time, and these are the quality. You have the precision to recall the if measure, which are the metric performance used to see if we did well or not. So for each of the three type of recurrent error, we show that with our implicit aggregation, we did well. I have also another way. Remember that when I list all the solution I called. I list the recurrent neural network, the graph neural network, the convolutional neural network, and so on. So we can do like this. We can parallelize each type of model, or we can also build a parallel domain specific language. So what is it? It is what I want to do here. I am doing it with another PhD student. So here it is to allow, instead of parallelizing individual machine learning model, we want to allow an automatic parallelization. So we implement all the proposed parallel machine learning algorithm on a parallel domain-specific language. But the question is, why another DSL? Because there are other existing DSL. And we call it fast ML. Fast ML is not the first one. We have others. But for example, OptiML, which is another DSL, did not succeed because it's not easy to use. And also existing machine learning tools are mostly Python friendly. I don't know if you know, normally if you deal a little bit with machine learning, already know about Python. They are, but we have many issues in performance with Python, and there are more library. So our goal here, when we decide to build another DSL, is to have a standalone DSL like OptiML. So that is not a library, but a DSL which is as efficient as a language like C, because in computer science we have many languages. And for example, Python is very easy to use, but it is not efficient. It's not easy to use, but it is very efficient. So we are looking for a domain-specific language that is both easy to use and also generate efficient code. And finally, we are looking for a language that is transparent to parallelism. For example, if you use the C language, you have to parallelize it, and usually we teach parallelism to computer scientists at level 5 or level 4. So parallelization is not an easy task. This is why we decide to build parallelism, parallel domain-specific language. Okay, here is an idea of fast ML. So this is we have a master here, and also we have a function. So we use the MapReduce paradigm to do it. So fast ML is, for this moment, is a set of template written in C. As already said, it is a MapReduce fashion. Is a model of parallelization, and the user have to define his data set, and also have to define his task, and precise how to aggregate these tasks. And so the first ML, the DSL that will do the job. So you can see if you want to look at it, you can download it here. So the question is where do the ethics concern will intervene. So it will be in dataset collection, so not in the computing. Finally, I am almost at the end. The result in FastML DSL. So we do experimentation on the 8-core machine. We compare K-means and linear regression. These are machine learning model, and we saw that we can, with FastML, we can have improve, or we can speed up we have a speed of 2.46, that is 2.5, or we can even have 3.5 as a speed up. But we are still working on this DSL. The next step, or the final step, will be to include in all our design models, because we have already parallelized RNN as I show you, but what I didn't show that is we also parallelize other like RNN, GNN, and others. So the final thing is to include this model, this parallel model in the DSL, so that computer science scientists will use them, and the parallelization will be automatic, and the code will be directly optimized. Okay, so I am at the end of my presentation. the main access in this this project, I just present you some aspect, is using machine learning based heuristics. So build heuristic that reduce execution time based on machine learning, or build parallel machine learning model, and finally build language, domain specific language. We already have a virtual doctor. Virtual doctor include, for example, the CNN model that we designed, and also other model. And also we design with a group of students behavior analyzer that we include in WhatsApp. So when people are discussing, we can directly say that this message is not good. For example, we can include it in HUMA group where we are discussing. So if a person say something that's not that is hate, the model we say that it is not good. And the three aspects that I present here were present here as paper DSL for parallelizing machine learning with Nel Namvu with PhD student, clustering bar graph numbering using execution trust for cache misses reduction in graph analysis application. This is Regis Mogo, another PhD student, and also parallelization of recurrent neural network training algorithm with implicit aggregation. So this was done with Donald Onana. So it is a master student. So thank you for your attention.
Thank you, Messi. Yeah, my head is still with lots of figures. But yes, it's a very rich, very instructive, and really deep insight into so many things. And I think we have so many questions about so many different aspects, because it's also really transparent in the ways in which machine learning works and understanding its components and processes. And the example about hate speech and ways of having to deal with it through modeling is also very. I was thinking about Matthias's work. Matthias was here. The other colleague from Brazil who was doing the work on digitalization and questions around race, and so, and also Georges and others. But we don't have a lot of time, but I'm going to take 1-2 questions. I know we still have time next week for retreat, which allows us to speak a lot, and we have Messi is here for close to 2 to 3 months. So there's still so many conversations and so many learnings to have. So Georges.
Thank you so much for the presentation. So my comment will be in the frame to show what the meaning, represent meaning for social science research science, for example, in the frame of science of English study. For the first one I want to take is the interdisciplinarities even ago, because sometimes it's very complicated for social scientists you working on technology to have the opportunity to engage with computer engineering, computer scientists, or engineer. Those are the first one, and I also thank you for the way you try to translate your knowledge in the way we can understand it better. And the first one is the question of predictability, such as that.
Right.
And it's a very important question, because today everybody, like we are living in this certain world, sometimes it's very important for us to predict what can happen on the financial market, on the society, the natural disasters, such as that. And the question of predictability is very important. So I found it very well. So thank you. The second point you mentioned is the division of labor. We propose how to divide labor so you can allow so tasks can be run at the same time when unit capital structure that you presented. But what I want to know is, do you think on the implication of this division of labor on the resources consumption, for example? So if the time you can create a parallelism model, if the divide can take more energy in terms of transformation. Another one is the implication of the power of the machine your model trying to design, because you can imagine that if, like we say in French, a computer has one head, 2 head, 3 head, they can do one can. This means that the computer has to be more powerful, and this means that the construction of those computers need to build on a lot of resources more than what is happening today. And the last point is the question of acceleration. You know, because the philosophy behind your presentation is how to go fast, how to do very quick, and how to accelerate processes. And this question is much engaged in critical theory in Frankfurt School, for example. I remember the book wrote by HUMA, Social Acceleration, who tried to make a critique about how technology wants to go fast today and the consequences this kind of acceleration, the consequences of this kind of process on our living, on our societies. So for me, this is the ethical issue we can get, but we have time to talk more about. Thank you so much.
Okay,
Thank you, George. I think I'll leave the other questions for his long stay here. But also you can select which one you want to respond to. It's a lot, and we're going to have so many conversations.
Okay,
Yeah.
Thank you, George, for your question. So that you ask a very interesting question, because we are actually in Cameroon with some master students. We are working on energy consumption. Yeah, and actually have not yet published this work, but we saw that when you use many cores, because the machine has, as we said, the machine has many cores. We saw that with the number of cores increasing, the energy consumed by the application is decreasing. But maybe, as you said, since we are using many core, normally it consumes we are using many machine resource. So for you, the energy should increase with the number of cores, but we realize that is not the case. But it is also explainable. Why? Because if you look at the formula of the energy, you see that the energy is what is the power time multiplied by the time. So we realize that the power is related to the core, the number of core used. But we realize that the time decrease more than the power is increasing. So this is the reason why the energy is decreasing with the number of core used. I don't know if you
Great. I think you're going to continue the discussion, and we are also interested in it. But thank you very much, Messi, for launching the seminar series and for accepting to come as visiting scholar despite heading a department at an institute. So, and we're also thankful to your university for allowing you, to come, because it's not easy, to let a colleague. But there is a program out, a tentative program that we are going to publish next week. We are not having a seminar, but we have a retreat. So the team will be away for a writing and also thinking retreat. But on the 21st of August, Abina Chiere, who is also postdoctoral researcher within the Carnegie AI initiative, but also a fellow at the University of Ghana, the Institute for African Studies, who will be speaking to us on a paper entitled Share the Link, the Phenomenal Rise of Digital Prayer Platforms and Communitarianism, which is also about the work in Ghana. And on the 28th of August, which I think is the one of the last days of Georges Marquet Iyenga here, he'll be speaking to us on digital population registries and artificial intelligence questions in Africa, which is the work that he's doing also in Cameroon, Ghana, and others. Yeah, but thank you for being here today, and thank you again, Messi.
Thank you.